All right, so this is LINSTOR Tech Days number 5 out of 6. Starting to get the hang of this. Today we're back with Michael and Yusuf. Michael's from OpenNebula. Yusuf is from LINBIT. He's the open source, or excuse me. Yusuf is from LINBIT. He's the solutions architect. Him and I do a LINBIT podcast monthly. It's a good time. You should watch it. And we also have Kuhn from ProcoliX, and he is going to tell us a story today about how they're using LINSTOR and OpenNebula.
Are we sharing it?
Yep, we're good.
Yep. Okay. That's what you already said. So, hello everybody. I'm gonna talk about taking LINSTOR and OpenNebula to the cloud. In a minute, I will explain what you're seeing there in the image for anyone who can guess. It's not the Tower of Sauron. So I'm the CEO of ProcoliX. Let me tell you something about ProcoliX. ProcoliX is a company based in the Netherlands. We are a managed hosting provider since 12/12/2000. That's not an accident. It's actually chosen date so that we could celebrate our 12th anniversary on the 12/12 on 2012. We have been working with LINBIT since ages, literally. Our first contact with LINBIT was back in 2001 when we did presentations with the distributed replicated block device. We've been using 100% virtualization since 2007. I will get back to that later. We're dedicated to open source. That's why we'd love to do this webinar in something else than Zoom soon. And we're serving cloud from the cloud. That's actually what's in the picture. It's a TV tower. Here in the Netherlands, there are not many hills. So if you want to broadcast video or radio, you build a concrete tower 200 meters high, and then you put your antenna on top of the tower. And these towers are now being used as data centers. So a little bit about myself. I said already, I'm the CEO of ProcoliX. I've been using Linux since 1994, back when Slackware was still a thing. I'm a strong open source evangelist. Be careful, I sometimes have very strict views on stuff. I'm a member of the board of the Dutch Unix user group, a group that still does frequent presentations of open source packages and open standards. I'm a hacker. I'm proud to be. Perhaps if someone has a question about that, let's come back in the question and answer section. And I'm a father of 3. You will see 1 today. And also something I find important, I'm a neurodiversity enhancing employer. And you might wonder what that means. It means I employ people that other employers might not find so easy to employ because they are other than others. They're different, and I like different. It's also in open source. So the things I want to talk to you about today are our challenges. We try to build a scalable and sustainable cloud hosting solution. I'm going to say something about public clouds, hosting, privacy, security. Our search over the years, what we've been doing with our infrastructure, why LINBIT and LINSTOR in particular, and why OpenNebula, how it all comes together, and how success is guaranteed in bringing freedom to the cloud. It's a very nice ring on the OpenNebula website. It says bringing true freedom to the cloud. For us, it's a really a specific thing, but I'll get back to that too. So let's talk about the cloud. I hate the word cloud. Cloud is nothing else than not your own computer. It's vague. It doesn't really tell you what it's about. But the nice thing about cloud is that people that don't understand anything about IT infrastructure can still talk about IT infrastructure by saying cloud. And if you ask them, what does it mean? Well, just cloud. Then there's hosting, something we do. Hosting is providing a service. It could be anything, but hosting in an IT perspective means something else. And then you have solutions. Solutions are a means to a problem. What we do at ProcoliX is we are sort of the equivalent of a group of IT construction workers. We build stuff. We design, deliver, and maintain IT infrastructure. The thing that makes your application run, the thing that solves your problem, the thing that you can rent from us in a hosting service, the thing that some people call cloud. There's a real cloud in the picture. That's when you get when there's magic smoke from your computer. So what are we trying to do? We're trying to design for sustainability. And with sustainability, we don't just mean green or good for the environment. We also mean durable, will keep working in the long run. And there's something about IT infrastructure that makes it hard. The hard thing about IT infrastructure is that it's very complex technology. And it changes every day. But even though it's complex and it changes every day, you cannot do without it anymore. If my internet connection fails now, this webinar will just go down the drain. So even though you call it agile or fluent or on demand, it has to work. Always on is the default. The funny thing is, back in 2008, we were promoting ourselves as high availability hosting. And that was a thing back then. Now it's a thing if you're not doing it right. And then very soon it's no longer a thing because you will no longer exist. So we've been building IT infrastructure and we've tried to do a lot of things, but there's a reason we're using open source, and we're using open source only. Let me tell you something about our experiences with other products. Back in 2005, 2006, we were building our first full open virtualization platform, and we tried to build it on something called Xensource. Xensource is the business of Ian Pratt. And that worked quite nice. We saw that it was a good system, and we bought into it. We spent 30,000 euros on licenses for Xensource servers. And then it got acquired by Citrix 2 months later. And 4 months later, Citrix announced that all the stuff we bought licenses for was now freely available. And there was nothing we could do about it. Then a few years later, in 2010, 11, 12, around that course, when vCloud was just starting. So the fun thing about this is VMware was very late to the game. About 4 to 4 years later than OpenNebula was. And it looked like quite an interesting product. And the nice thing about it was, if someone had VMware on-premise, you could just move their VMs to your cloud system, and then you could run it with the vCloud and they could manage it themselves. And it worked sort of, not as fluently as OpenNebula in our perspective, but then something happened, and it's been happening since, over and over again. And this is the last one I could find, April 17, 2020, new pricing on the VMware Cloud Foundation for cloud providers. So if you're a small cloud provider, you are paying a lot of money for software that you then are still limited to use. But storage is also a thing. So even though we had LINBIT and we used DRBD in a lot of places, it was not really usable until about a year ago for selling it to how do you put that nicely? End users that are not working daily with storage. They want to have like a graphical interface where you can click on stuff and it just works. LINBIT has that now. It's called software-defined storage, vSAN. So we had a nice product called CompuVerde, also from Europe. It's from Sweden. And we were actually doing quite well with that. And then Pure Storage acquired CompuVerde. And now the product is actually finished. The latest support will be until 2024. And then you have to stop using it because your license runs out. So the result is it's very hard to build a 5+ year plan. And it's very hard to do that anyway in the IT infrastructure, because you won't know what happens in 3 years. But with open source, if a company gets bought, like for example, MySQL gets sold to Oracle, you can still use the product and you can still get development on it. And chances are that someone else will take that development and actually improve on it, like with MariaDB. So open source gives you options, and that's why we like and love and only use open source software. Now there's a thing about the cloud that is very important that we also feel strongly about, and it's about privacy. Here you see a picture of my youngest daughter with our dog in the sun, and it's a really nice picture. Now imagine my daughter wasn't wearing anything. Would you want that picture to be in Dropbox or in Google Drive or in Amazon, when their terms of use explicitly note that they can use your content to build a good marketing picture of you? Well, the answer is simple: you wouldn't. So these pictures are hosted on-premise in our own house, and a backup is made, encrypted, to one of the trusted service providers. That's exactly what you want. And that's something that you can do only if you have full control over the software that you're running. So you can run your own on-site OpenNebula deployment with LinStore, and it will just work. And you don't even need your enterprise contract to do that. You can just download it, install it yourself, and use it. And that's a real powerful thing. So this makes us able to actually run something on-premise. And this, as far as privacy goes, security and privacy are not only things for individuals, they're also things for businesses. You don't want, if you're a book company, you don't want your company details hosted with a competitor book company called Amazon. That's a really weird thing to do. So you host it on site, you can make a backup, or you actually take it to a data center nearby. So that's where the word edge also comes around the corner. And what I like very much, and we'll get back to that later, is something on latency. Latency is important. So if you're doing video conferencing with more than 5 people, let's say we would ask all the attendees to turn on their cameras, you need, for a good experience, you need low latency. So the closer you can put your video conferencing software to the end user, the better it will work. And again, you can do that with OpenNebula. Now, let me tell you something about our stroll along the virtualization and orchestration options. So 15 years ago, getting something that just worked was the most important part, and that you had to do a lot of stuff to get it working easily. That was not really an issue. But the further you go into the future, the easier it has to be to actually be usable, which is why the support for stuff like Equinix bare metal is very interesting. But we've used all these solutions, and I want to highlight two of them. And that's also the two people you see, and they are very important. To the right is Mr. Ian Pratt. Ian Pratt is the inventor of Xen. Like Lars and Philip, he invented Xen when he was in university, and he made a business out of it called Xen Server. That was then sold to Citrix, which I've already told. On the left of him, in the middle bottom of the screen, is Avi Kiviti. Back in 2007 or 6, I had lengthy IRC conversations with Avi, if we might be able to use KVM. But they had a Windows interface that was then sold to Red Hat, later called Red Hat Virtualization. And it was nice, but there were single points of failure on it, so you couldn't really run it in a high available way. Then we looked at OpenStack, and we saw a lot of OpenStack implementations with our competitors fail because OpenStack changed so much, and it's a collaborative system. So you're being drawn between the different participants in this environment. Then we have tried CloudStack. That was then sold to the Apache group and sort of abandoned, in my view. It worked, but it was also very limited in how do you put it? You couldn't really change parts of it to make it your own, which you can do with, for example, OpenNebula. Then we looked at Xen Orchestra, which is built by a company in France, which is also nice. But Xen Orchestra is not open source. And I do not want to be back in a place where Xen Orchestra gets sold and then you have no support anymore. So that wrote off Xen Orchestra. And then you have Proxmox. And Proxmox is quite nice, but it lacks the federation and zoning and stuff that OpenNebula has. So we see OpenNebula actually as the cloud platform of the future. And the more we learn about it, the more we think that this is the right choice. And it could be the story of Highlander. I hope it will be the story of Highlander. So in the end, there will be only one. And it's nice because it goes back to one again, you see? One. So if you're building a cloud system, storage is the thing that makes or breaks it. So you can build a really nice OpenNebula cluster and then put it on Ceph. And it will probably work to a certain extent. And then you put a lot of workload on it, and then one of your Ceph nodes fails, and then you're in trouble. So let's say you build a reasonably sized deployment of 10 systems for your Ceph cluster, and one of the nodes fails. It can take days or even weeks before it's rebuilt again. With LinStore, you don't have that problem. You can even start out with 3 nodes, and you know that if one fails, it will relatively quickly rebuild. And that's because it's just a lot older, in my view. We've looked at other options like ZFS-based solutions. By the way, you can use ZFS in combination with LinStore, but the ZFS storage we used previously was built on shared hardware, and that doesn't really scale well. So you will have to build different sets of hardware. With LinStore, you can just start out with like a 5-node cluster or a 3-node cluster, and then so I mean an OpenNebula cluster that has the hardware, the storage hardware included. Then you can just scale out by adding node by node nodes, and this scales enormously. It can go up to hundreds of nodes. That's also really nice. So I'll speed it up a little bit. Why LINBIT? well, because of these people, and because it's 100% open source, it has a sustainable model, it offers high availability, shared nothing storage, thin provisioning. It's very well integrated with OpenNebula. There's a professional organization. You see, these people are really, how do you say that? Nicely dressed. In normal day-to-day use, they don't look this sharp, but still. They're really nicely dressed, and it's a European product. So that means I can just pick up the phone, and I know that when I call at 5 o'clock, Philip or Lars will be awake. And then when they're not, in the middle of night, I can pick up the phone and call Brian, and I know that he will be awake. So that's really nice. I will switch forth and back a few times. You see that they have the same characteristics. OpenNebula is also 100% open source company. It has a sustainable model. It has support for multiple technologies. With OpenNebula, I can still import my VMware VMs and use it, and then slowly migrate them to a more open system. It's multi-tenant, very important. It has full API support. It's integrated with LINSTOR. It's a professional organization, and it's a European product. I can try and call Tino, and I will know that he's awake. And the same goes for the middle in the night support. There's also people in the US. So how does this all come together? We are doing hosting. Hosting means we offer stuff as a service, but we also host on-premise. So if you want to have a tailored solution, something that works exactly for your need, we can do it for you. And you can start out really small, but we can also do really large. And then we don't need anything else. We just need OpenNebula and LINBIT. And that makes it simple. And it gives us the opportunity to grow from local to national to continental to maybe the world. There's also an open source meme, of course. Something, something, world domination. So a word on sizing. How do you know how to start? Well, there's two ways. You look at what you need, but if you're a hosting company, you need something you can sell, and the more you can sell, the better it will work. So you need something that scales. So how do you then start? Well, it all starts with physical space. You take a rack, and then you try to balance the amount of money you put into that rack with the performance you get from it, and the power it will use, and the time it will take to maintain it. So we have something that's called distributed edge data centers. We have these TV towers all over the Netherlands, and we are going to put a data center in each TV tower. And then we're going to put an OpenNebula LINSTOR deployment in each TV tower. And these TV towers will be interconnected with dark fiber so that you can have a real edge implementation, like a few kilometers from where your business is. And then we've sort of determined a nice amount of compute, storage, and other resources. So a minimum set that we use consists of 5 hosts, 4 + 1, so 1 for redundancy. Each host has at least 256 gigabytes of RAM. In practice, it's already more than that. 48 cores. I prefer the AMD CPUs because they're one CPU, a lot of lanes. At least 25 gigabits of Ethernet, more if possible. And 10 to 12 terabytes of all flash storage per node. And that makes a really nice set of about 1 terabyte of RAM with about 50 terabytes of usable storage in 5 hosts with redundancy. Something else we're doing, which is worth mentioning, I think, is we have the IPv6 unless approach. So that's something that was hard with VMware, that's still hard with Xen Orchestra. we are not in possession of huge amounts of IPv4 space. Companies like Equinix are, because they are big and they exist for a long time, but we have a limited amount of IPv4. And IPv4 is over. The future is IPv6. So we're starting out with IPv6 unless you can get IPv6 addresses from us. As much as you need, as much as you want. But if you want IPv4 addresses, you have to pay for it. And the more IPv4 addresses you want, the more you're going to pay per IP address. I can imagine that we will get questions about that later. So we're bringing freedom to the cloud. And that's nice because we are actually working together with an internet provider called Freedom Internet. Here in the Netherlands, there's the first internet service provider in the world called Access for All. They were sold to our previous a national telephone company, and Access for All has been sort of eliminated 1.5 years ago. It still exists in name, but the whole idea around it, where privacy, sustainability, fairness, transparency, and federation is something that were core values of this company are no longer there. And this is what Freedom Internet is doing. And we are going to bring Freedom Internet literally to the cloud with OpenNebula and LINSTOR. As you can see in the picture, the data centers we have in these TV towers are often in or above the cloud. And then I don't mean the cloud in a metaphorical way, but in the physical cloud, in the clouds. So we're bringing freedom to the cloud, real freedom. A small view of what's happening and what's going to happen. This is a map of the Netherlands. I can imagine if you're from the United States, you don't even know where the Netherlands is, but look it up on the world map, I would say. And this amount of land is about the size of, I would say, New York State, right? And then we have in the center, we have Amsterdam, which is where all the internet from across the sea is coming in to Europe. And we have 3 data centers there, and then we have data centers a bit away from that. And we're going to build small regional edge data centers in all of these TV towers. Now you see all the small red dots. Those are not places where we have an outbreak of corona, but those are the places where the TV towers are located. So if you want to fill the map with places where there's an outbreak of corona, all the dots would be red. So what are we going to offer with OpenNebula and LINSTOR? Right now we're only offering infrastructure as a service, but we're going to expand this to hybrid IT infrastructure. So you can get an OpenNebula LINSTOR deployment on-premise, where as a backup measure or disaster recovery measure, you can replicate that storage to our infrastructure as a service facility, where if needed, you can spin up the VMs that you have in your local OpenNebula deployment. And then by the end of this year, we will probably be serving public cloud infrastructure together with Freedom Internet, where you can just get one VM or a whole set of VMs, or do cloud bursting, or all the stuff that you might want to do with OpenNebula. And then on top of these 3 types of service, we will do managed. And managed means we will design it for you. So with infrastructure as a service, it's like, I want to have a garage where I can put my car. And then I'll say, okay, we say we will build you a garage. Here's the garage. You open the door of the garage. With on-premise and infrastructure as a service, it's the same. But if you want to have these things managed, you're not going to ask for a garage. You're asking, I want to have a place where I store my car. And we will build everything for you. And then we will deliver this from the edge from all those data centers around the Netherlands, so that you you're always really close. Well, that sort of concludes the presentation up till now. Are there any questions? As you have seen, I've not talked too much about technical stuff. I am, however, very much open to very technical questions, and I'm happy to answer them all. Can I see the question somewhere? Ah, here. Oh, shall I read it out, what it says? So we have anonymous attendee here that says, Koen, I cannot agree with you more on cloud definition. For 20 years, I was building data centers. Suddenly, cloud providers called them cloud, patented that term via social consensus, and told everyone not to build data centers anymore, and moved their version of data centers called cloud. And then a smiley, of course. Yeah, thank you. Any other questions?
While we wait for some folks to put in some of their questions online, I think maybe Yusuf and I can take an opportunity to at least pose a few questions or comments to you. And I'd like to start because I think it was very interesting, your presentation, and really just explaining the synergy that you found between ProcoliX and both LINBIT and OpenNebula. I was going to ask you, specifically to kind of address, in relation to OpenNebula, comparisons, with not only you pointed out the commercial products like VMware, but some other open source solutions. You actually went through in good detail and provided some keen insight into where you see some of those products may be lacking, where OpenNebula has helped out, and that was great.
Yeah, actually, I don't much competition right now. So OpenNebula seems to be the product that does it all, and stuff like OpenStack that still a lot of people are very enthusiastic about. It doesn't do federation, so you can install an OpenStack, but then it's just that OpenStack. And if you need then something somewhere else, you can't do it. So this is, I would say, true cloud, but true cloud is sort of a misnomer. So true scalable infrastructure. Okay. Sounds a lot more boring, doesn't it?
Well, that's perfect, because I was going to lead into my question. Right now, I think most of the folks, even in previous sessions, kind of seeing what we're doing with OpenNebula 6.0, right, and then really kind of bringing capability to allow folks to create, really what we're calling a true hybrid multi-cloud approach. And I kind of wanted to just, maybe you can quickly just highlight how important you think hybrid cloud capabilities would be for your business.
So I would say this is what will make our business rock in the coming months to years, because the fact that you can make an on-site deployment, fully manage it from a centralized place, while giving your customer access to all the knobs and buttons they want to turn, and then if something fails, even if there's a fire or a flood or overheating of the service room, you can still move it to your centralized or edge data center, and that's a real feature. It's something that's, and I also think that you need LINSTOR to do that properly. So if you want to try and do that with Ceph, you will have a hard time copying all the data all of the time. Whereas with LINSTOR, you can use a product called DRBD proxy, integrate it into the product, and then you can even do it over a very congested internet connection. Yeah. Let me go into this question here. Can you go into a little more detail about IPv4 and IPv6 gateways? Yes, I can. So what we're doing is we are building a native IPv6 network where all of our infrastructure will be fully addressable using IPv6. And then we're probably going to use something called SIIT, which is sort of what you do is you basically network address translate the whole IPv4 internet into the IPv6 network. And then you sort of port forward. That's the analogy I would use. The traffic that comes in on a certain IPv4 address to that one IPv6 address. What we're also going to do is provide clustered, high available load balancing kind of setups where you can have where you can use our front-end service to redirect your IPv4 traffic to one or more IPv6 addresses. And we hope to integrate this into the OpenNebula product so that you can actually just say, hey, I want an IPv4 address for this host. Click here, click there, and then all the traffic for that IPv4 address that you can buy from the pool will be redirected to the IPv6 stuff. I don't know exactly how that works because I have a team that does that. And if you are interested, please get in touch and we're happy to talk about this. Then we have another question. Do your customer have the capability to provision their own networks? Are you leveraging VXLAN? Currently, we're looking at VXLAN in combination with Open vSwitch. And it is a very interesting thing to do. But if you go to that first part of the question, do your customer have the capability to provision their own networks? We have customers that bring their own IPv4 space. And then we just route that IPv4 space for them, and they just plug that into their OpenNebula. We plug it into their OpenNebula part, so they can use their own IP space. The VXLAN stuff is something that requires a lot of adjustment to the rest of your network infrastructure, and we're still looking at that. Though we are very interested to do that, we don't have it in production right now. So. About networking, by the way, we are building a BGP network that works internally between all these TV towers. And currently we have 3 towers, 2 conventional data centers, and 2 sort of partner data centers, the Freedom Internet, where Freedom Internet is located. And these are all interconnected using dark fiber. And that once again makes it very scalable. And now if you're from the States, you probably think, wow, dark fiber, it's really expensive. And it's still relatively expensive from our perspective. But in the Netherlands, there's fiber everywhere. So yes, there's still places where there has to be done some digging, but that's usually just a few dozen kilometers. So let's say a few dozen miles, and not hundreds or thousands. And it's all relatively close by. So when you have dark fiber, you can actually, over one dark fiber pair, you can do 64 times 10 gigabits easily. It's not even that expensive. And that also scales your scales very well for your network requirements. So if you want to do a hybrid LIN store across 3 TV towers, that's something that we can do already. You have to have a use case for it, of course, but it can be done.
So the idea on all these TV towers is to provide internet for everyone through antennas or something.
Well, they are those towers are serving antennas. There's still radio and TV being broadcasted from it, but that's not really how would you put it? The main way of distribution of digital content anymore. So most digital content is just being served over the internet.
Yeah.
So what's happening now is that these towers are partly repurposed as data center facility. And we are leveraging that repurposement for bringing localized edge, which is again such a buzzword. So every time I hear edge, I see an XKCD image where you have a cliff, and then there's a TV tower on the edge of the cliff, right? And then there's clouds above. Maybe we should ask Monroe to actually draw that image. But if you want to host your own physical hardware, which is also still something we allow, it's very nice if you don't have to drive for 4 hours or 5 hours to get to the place where your physical server is actually located. So one of the things we're aiming for is that within the Netherlands, within an hour's drive of your home, your physical home, you can bring your own computer hardware and put it in our facility. And then you can run, for example, your Nextcloud photo archive, where all the nude pictures of your wife are in this archive, and run it on your own hardware, and then still use the encrypted backup facility that we provide to store it in one of the other TV towers, so that if someone sends a plane into one of into the tower where your hardware is located, you can still get the pictures of your wife back. And as you know, it's very important. And if your partner has makes a picture with their phone, it never gets lost. That's one of the first needs of life. Yeah, I'm
Very true.
But there is a form of truth in it. So it's the same with TV, right? So TV in the Netherlands, you can almost only get IPTV. And it's worse than the old analog cable TV. Because what happens is you need a computer to actually decode that TV signal and get it into a moving picture. But these little boxes, they tend to crash. They're not high available, so you have to turn them off and on again to get your picture back. But then when you've paused your video image to get some crisps and a new glass of tea or a new bottle of wine, and the box has crashed, you actually want your picture to be back. That's where, once again, OpenNebula can play a part, because then when you have localized OpenNebula clusters where you can run your video conferencing, would be really nice.
Yeah. So we have 2 more questions, Koen. Before we close, one of them is, how is the storage performance? So what I can say on behalf of LINBIT, so the storage performance would be just fine, because the RBD is working on the kernel level. It's a kernel driver. So on the replication, it will be like, I don't know, unmatched in kernel data replication. So you will have pretty good IOPS from that machines. And just to mention that we have the world IOPS record with LinStore plus the RBD, which is like 14.8 million IOPS in a cluster.
Let me show you this picture.
Yeah.
So this is one of our clusters. On the right, we have 6 3.5 terabyte NVMe devices in these servers. And the question how is the performance? The answer to it is it couldn't be better. So performance is never our bottleneck in these setups.
Always the network, right?
The bottleneck is the network, but even there we have Mellanox 56 gigabit switches, which is an older generation Mellanox, but still dual 56 gigabit interconnect gives more than enough. So the real bottleneck in our servers is the amount of RAM that's in the server and the speed of the bus, which is a really nice place to be. So if we have for example, we host the Salvation Army website, and if then they have a problem that their database cannot go any faster, we can say, hey, if you put an index on your table, the CPU can do it faster, because you're now actually clogging the CPU with weights because you don't have an index on your database table. And that's, sometimes we get the question, can you not just get faster hardware? And then I say, yes, we could. I could replace all these normal NVMEs with Optane cards, but it will be 10 times as expensive, and you will only get 50% faster.
Yeah.
And then they understand. So the performance of the hardware, well, doesn't really matter.
Yeah.
Got one more question here, and then we got to wrap it up, unfortunately.
I see.
Looks like two, unless you want to try and squeeze them both in.
Oh, I will. So let me first, because the first one is again about network virtualization. So given your experience in the ISP business, is there potential to use OpenNebula with NFV, network functions virtualization, or is it not what OpenNebula was created for? So there's a part of the answer is already in the question. That's very good. Yes, you can use network functions virtualization, and it's really beneficial, I think, to the use of OpenNebula. But that's not what OpenNebula does. So the interfaces are there, and you can do it, and I think you should try. But then any new technology that you might think of is interesting. So that's not really, how would I say it, a very precise or accurate technical answer, but I think yes. And then, is it possible that data may corrupt or lost because of RAM exhaustion used by the replication layer? By RAM exhaustion specifically, now the way that so DRBD LINSTOR is also very specific. So if we go into LINSTOR can also be used not only for DRBD but also for NVMe over Fabric.
Yes.
So you can use LINSTOR as an orchestration layer to replicate data using NVMe over Fabric. Now this is very deep dive into the storage world, but let's go back to DRBD. So the last time I saw corruption with DRBD is more than 12 years ago. And the reason it got corrupt, because I made it so. So if you actually say, yes, please overwrite this data, the software will do that. The nice thing about LINSTOR is that it takes care of a lot of this. And the main place I would say you can get corruption or data loss is when more than one device fails at the same time, or when you do something explicitly wrong. RAM exhaustion, however, no, I don't see that happen.
I don't think so. Yeah. So and one more thing to say, and the DRBD and LINSTOR is using really low CPU and memory utilization. So I really don't think that would be a case in any situation.
Yeah, we could go into the technical details and talk about extents and stuff, but
And let's talk this question in the Q&A session in couple of minutes.
oh, that's a good
Because the
idea.
DRBD technicians and LinStore technicians will be there, so it will be best if we can talk this later on.
Very well. Thank you very much for having me. I'll be happy to do those other LINBIT podcasts.
Yeah.
Yeah, we'd love to have you on there. This is
Yes,
an awesome
definitely. We love it.
presentation. This is one of the best ones I've seen. So very good. Thank you very much.
Thank you very much, Colin. It was really great.
And thank you for the audience. Also nice
Fantastic.
people. Perhaps we can do one with the video on for all the participants.
Yeah, we could do that. Again, like I mentioned, Yusuf and I do a Lincast. Maybe we could have you on there one day and we just talk tech is all we do.
Yeah, nice.
So it's fun.
Nice, good. Okay.
All right. Thank you guys. We'll talk to you soon.
Yep.
Great. Thank
Bye.
you very much.
Bye.